In this video, we're going to review the scientific method. You've heard about the scientific method before in other science classes. It's particularly well suited to chemistry because it's a way of developing and using the results of experiments. So the scientific method is a way, it's not the only way, it's a way to think about advancing your understanding of a subject, a scientific subject, and sometimes not even a scientific subject. It's used in other fields as well. It's not the only way to think about science, but it is one way for scientists and people who are studying other things like education and medicine and social sciences. It's a way for them to organize their thinking. So what are the parts of the scientific method? The scientific method has 4 steps to it. Here they are. We'll go through them one by one in a minute. And then there's sort of a side pathway that sometimes comes up as well. So when someone is going to use the scientific method to try to improve their understanding of something, they start out by gathering information about what they already know. So they might make observations. And the word observations, in this case, means a few different things. So it could be things that scientists actually use their senses, their sight or their smell or taste or their feel to gather or measure. But it could be the results of other experiments that either they or someone else has done. And it could be something that they look up. So they might research the current understanding of something and then try to add to it. So those things, all of those things could be part of the beginning phase of using the scientific method. So once the scientist has an understanding of what's already known about a particular subject, then the scientist will try to develop a hypothesis. A hypothesis is a proposed explanation, so we're going to try to explain why when we make a hypothesis for an observation or a set of observations. So we're proposing an explanation for the things that we've read about or the results of experiments that we already know about. A hypothesis should be testable. In other words, we want to say whether the hypothesis seems to be right, seems to be supported, or seems not to be right. So this implies that once we make a hypothesis, we're going to develop an experiment to test that hypothesis. And yes, that's the next step in the scientific method. Once we have a hypothesis, we're going to test it using some experiments. Experiments test hypotheses. During an experiment, we're going to make some new observations. So we don't want to confuse the term observations. The observations in the scientific method are what we know about when we start, but we're going to make some new observations as part of the experiments phase of the scientific method. And when we get the results of our experiment, we're not going to be able to say, based on one experiment, whether that proves or disproves a hypothesis. Those are not words that we want to use. But an experiment will tell us that whether our hypothesis is supported or not. And but a single experiment doesn't prove or disprove. And that leads us to these arrows on our diagram here, these green arrows. In order for us to be able to say with confidence whether a hypothesis is a good one or not, we have to do many experiments. So the experiments that we do have to be reproducible. And also, if the experiments don't seem to support our hypothesis, we may have to change our hypothesis. So there's really 2 things going on with these green arrows here. We're going to test over and over again our hypothesis, and we might alter our hypothesis or come up with some sort of a new hypothesis as we go along. All right, once we've done many experiments and they seem to support a hypothesis, this might lead us to a theory, a scientific theory. And a scientific theory is a well-tested explanation, well-tested, many experiments, for many different observations. So we have a set of observations, we test them, we do it over many different experiments, and we might be able to come up with a theory. A theory is an explanation of why something happens. And a theory, while scientists often accept the theory, many scientists may accept the theory, that doesn't mean that it can't change later on. Theories can change. We will study the theory of atomic structure. And over the last 200 years, that has changed significantly because scientists found new information, or new ways to measure things. So theories can change. So these green arrows here between the experiment step and the theory step tell us that there are many experiments needed for us to come up with a theory, and the theory might change over time as we get new information from new experiments. So a theory is an explanation that develops out of experiments as part of the scientific method. All right, sometimes the results of experiments or the results of a set of observations lead to a scientific law. If we get some information but it doesn't really explain why something is happening, it just explains that something is happening, that might lead to a scientific law. A scientific law is a summary of many observations or the results of many experiments. It doesn't explain something, but it does say what happens. So for example, the law of gravity is an example of a scientific law. So you and I know that if I take this little rubber ball that I have in my hands and I let go, it will fall towards the surface of the earth. Just like that. It bounce back, of course. But that is the theory of gravity. So scientists and other people over the years have dropped many, many, many objects, and every time they drop an object like this one, it falls to the surface of the earth. And so that has become such a, that is something that has been seen so many times that scientists say that's a scientific law. When you let go of something that has a certain amount of mass, it will fall to the earth. And there's no attempt to explain why, but we can say with confidence, because of the number of times this has been tested, that when we let go of an object, it will fall. So scientific laws summarize a whole bunch of different experiments or observations without attempting to explain them. All right, we're going to use the scientific method from time to time, and we're going to see some of these terms we've talked about today come up when we do experiments and when we write reports about those experiments. So sometimes we will develop a hypothesis or use a hypothesis as a basis of an experiment. The observations that start the scientific method will often find their way into the introduction of a lab report, and we're going to put our hypothesis at the end of our introduction. So the hypothesis grows out of the observations. Once we have a hypothesis, that will lead us to the experiment. And the things that we're going to put in lab reports, like safety rules, materials, and procedure, the procedure, all gathered together, all make up the experiment that we do. And the experiment will depend, exactly what experiment we do depends on the hypothesis. So we're going to have an introduction which contains observations and ends with our hypothesis. Our hypothesis is going to cause us to do a certain experiment. We're going to describe that with our safety rules, our materials, and our procedure. And once we do the experiment, we're going to get some results. And the results of that experiment will either support or not support our hypothesis. It's not bad if the results do not support the hypothesis. Either way, we learn something. We either learn something about how good our hypothesis was, or we may learn something about how we designed or did our experiment, but we want to be honest about what the results tell us about our hypothesis. to see some of these things as we do experiments and as we write about those experiments and as we go along. So there's a little summary of the scientific method.